Hello everyone and welcome back. In this video we're going to talk about comparing two different population proportions. And the way that we will compare two different groups mathematically is by looking at the difference between their proportions. So what we want to develop is a sampling distribution model for the difference between two population proportions, which we'll call P1 and P2. So what we want to determine is the standard deviation for the difference between two proportions. So if we're given two populations proportions P1 and P2 with sample sizes N1 and N2 respectively, then we can find the standard deviation for the difference as follows. So for each of these groups, we can calculate the standard deviations for their sampling distribution models by using the square root formula given here and here. So in order to find the standard deviation of their difference, we first calculate the variance of their difference, and then we take its square root. So if we use the properties of the variance, we note that the variance for the difference between the two sample proportions will be equal to the sum of their individual variances. So the variance of P1 hat minus P2 hat is the sum of the variance for P1 plus the variance for P2. Now what is the variance for P1? Well, that's the square of the standard deviation. So if we were to square the standard deviation, this would get rid of the square root. And so the variance of P1 would just be P1 times 1 minus P all over N1. And similarly, the variance of P2 is the square of the standard deviation. And a similar calculation showed that the variance will be P2 times 1 minus P2 all over P2. So this is the variance of the difference between P1 and P2. Now that we have the variance, we can find the standard deviation by taking the square root. And so the standard deviation for the difference between the two sample proportions will be given by this square root formula. So under certain assumptions and conditions, the sampling distribution model for the difference between two independent proportions will be a normal curve. And the mean is going to be centered at P1 minus P2, so the difference between their population proportions, and then the standard deviation will be given by the square root formula that we had derived. Now, as always, there are assumptions and conditions that needs to be checked whenever we want to use this normal model for the sampling distribution. So we have the usual independence and sample size assumptions, which are checked by the randomization and the 10% conditions and the success and failure conditions for each of these groups. But we also need an extra assumption, and this is called the independence group assumptions, which says that the two groups that we're comparing must be independent of each other. Now, because we don't know what the true population's proportions are for P1 and P2, we need to estimate the standard deviation, which is called a standard error, by using the sample proportions. So the sample proportions for group 1 is P1 hat, and the sample proportions for group 2 is P2 hat. So we can estimate the standard deviation by using these sample proportions. So if those conditions are met, then we can find a confidence interval for the difference of two proportions. And this is called a two proportion Z interval. So the interval is given by the estimate between their two sample proportions, so P1 hat minus P2 hat, plus or minus the critical value, which is Z star, multiplied by the standard error, where the standard error is given by the square root formula. So let's take a look at an example of finding a two proportion Z interval. Let's suppose that we want to compare the effectiveness of two different therapies. The criterion for comparison is the probability to survive at least 5 years after the therapy. And so we obtain the following data. So let's determine a 95% confidence interval for the difference in their proportions. So let's first check the assumptions and conditions that are needed for finding the confidence interval. So first we have the independent responses. And so within each group, the survival rate of one person should not affect the survival rate of other people. We also need independent groups which means that the survival rate of one person in therapy 1 should not affect the survival rate of people in therapy 2 and vice versa. So the survival rate of a person in therapy 2 should not affect the survival rate of people in therapy 1. And so we need to check for randomization. Now we're not given that we have random samples for each of these groups. And so we need to assume that the samples are representative of the population. We also have the 10% condition. So we need to assume that the sample sizes are no larger than 10% of the population. And then we also have the success and failure condition. So we need to have at least 10 successes and 10 failures for each group. So in therapy 1, we have a sample size of 100. The sample proportion is 90 out of 100, which is 0.9. And for group 2, we have a sample size of 80, and the sample proportion is 70 out of 80, which is 0.875. So now we can calculate the success and failures for each of these groups. So n times p for group 1 is going to be 100 times 0.9, which is 90. And n times 1 minus p is 100 times 1 minus 0.9, which gives us 10. So we have at least 10 successes and 10 failures in the first group. And for group 2, we do the same calculations. We have 80 times 0.875, which gives us 70. And n2 times 1 minus p2 is 80 times 1 minus 0.875, which gives us 10. So all of these are at least 10, so the success and failure condition is met. So now we can find our confidence interval. So first we need the difference between the sample proportions, p1 hat minus p2 hat. That's 0.9 minus 0.875, which is 0.025. The critical value for 95% confidence is 1.96. And the standard error for the difference between P1 and P2 is given by the square root formula. So we have the square root of 0.9 times 1 minus 0.9 over 100 plus 0.875 times 1 minus 0.875 all over 80. And this is approximately 0.04761 and so on. And now we can determine the confidence interval. So we take our estimate of their difference, which is 0.025. We add and subtract the critical value, which is 1.96, times the standard error, which is 0.04761. So that is 0.025 plus or minus a margin of error of 0.09322. And so our interval is from negative 0.068 to positive 0.118. So what we could say is that we are 95% confident that the true difference in proportions is between negative 0.068 and positive 0.118. So notice that our confidence interval is from a negative value and a positive value. So since we are taking the difference between two proportions, the values themselves can be negative. So based on our confidence interval, are we able to conclude that one therapy is more effective than the other therapy? Well, because our confidence interval includes 0, then we cannot conclude that one therapy is more effective than the other. So when are we able to conclude that one therapy is more effective than the other? What would the confidence interval need to look like? Well, let's suppose for the moment that the confidence interval that we obtained was between 0.068 and 0.118. So the difference between P1 and P2 is somewhere between 0.068 and 0.118. And so if our confidence interval is entirely positive, then this means that one of the proportions is larger than the other. And so if P1 minus P2 is some positive number, then this tells us that P1 is larger than P2. So in this case, we could say that therapy 1 is more effective than therapy 2. So now let's suppose again that the confidence interval we obtained was from negative 0.118 and negative 0.068. So now if our confidence interval was entirely negative, that means the difference between P1 and P2 is some negative number. And so this tells us that one of the proportions, again, is larger than the other. And if P1 minus P2 is negative, then this tells us that P2 is larger than P1. So in this case, what we would conclude is that therapy 2 is more effective than therapy 1. And if our interval is between a negative and a positive value, which means that the interval includes 0, then we can't make any conclusion about whether one therapy is more effective than the other. And so this concludes our lesson for this video. In the next video, we will talk about testing for a difference between two proportions, and I'll see you then.